Next, I'd like to take a look at some access control list scenarios and have us build some ACLs, look at some unusual cases and how that can affect us, as well as see when and where we need to apply those Cisco rules of applying standard access lists as close to the destination and extended access list as close to the source. So let's start off with this example here. So I have three PCs on the left, 172.1930.96, 97, and .8. And then over on the right, I have a Linux server for SSHing, a web server, and a DNS server, all over connected to router B on the 192.168.42.0 network. We're going to assume that these two routers have all of the routing configured correctly. So all we're going to be working with here is access control lists. So let's use this first example. Now, this is something that becomes very useful in a network, and we can use it to solve a problem should it arise. Okay, so here's the scenario. It appears that there is a virus on the computer 172.1930.8, and it's sending lots of traffic attempting to compromise the web server and many other devices throughout the network. So my request here is use a standard access control list and prevent that single device from sending traffic onto the network to prevent infection of other devices. The access control list here is actually going to be pretty simple. So I'm going to create a named access control list. I really am a big fan of the named ACLs. The numbered ACLs are equally as effective, but a name is so much more powerful when we're trying to write and manage access control lists on devices compared to just a number. So we'll make a named access control list. It's called stop virus, and there's only going to be one deny statement in it that we need, which is deny host 172.1930.8. Now the question is, where do we apply this access control list? According to Cisco, Cisco says that standard access control lists are always applied as close to the destination as possible. Well, where is that in this case? We have a device that's attacking all the networks in our system. Well, Cisco is going to say that since the web server is one of the devices being attacked, we should put it on F01 in the outbound direction. Now, I completely disagree with this. This will solve part of the problem, but not all of the problem. And secondly, there's a bigger problem here now. So if I do apply that access control list to F01 in the outbound direction, what's going to happen? What traffic is going to be allowed? What traffic is going to be denied? Take a second to examine this and think about it for a moment, and then we'll come back in just a minute and explain what is actually happening here. Well, we're back. Now, what's going to happen here? Well, if we remember correctly, the last line of every single access control list we create on Cisco devices is deny any. So what we've just done here is we've created an access control list that says, oh, deny this one host. So if the source address is 172.1930.8, deny that address. And then the second line of the access list that's not written there is deny everything else. So effectively what we've done is we've set an access control list in F01 that says don't allow any traffic in at all. So what we're going to have to do is we're going to have to add a permit any statement to the last line of our access list in order to allow the rest of the traffic to get through to our Linux web and DNS server. That way, if the device 172.1930.97 wants to access the web server at 192.168.42.80, we can do that because now it'll hit that permit any statement and just won't be automatically denied. So whenever we're working with these statements where we're just denying a single host, we really do have to make sure that the lines after that have permit statements so that we can allow traffic through and not just implicitly deny everything. But now I'm going to argue that this is not the best place to put this access control list, because what if in the future, or what if currently, there are two extra networks connected to our systems there that we don't really know about? Now I'm making up this interface F02 on my router, but that's not uncommon. The routers that I have here are 1841 routers. They have two fast Ethernet interfaces. But when you get to bigger and bigger routers or layer 3 switches like the Catalyst 6513 switch, you can have up to 12 48 port line cards in that switch, and each one of those ports could be on a separate router interface. So you could literally have hundreds or thousands of router interfaces on a single device. So having more than 2 Ethernet interfaces on a router is actually quite common. So what if we had these other networks attached to our router, and that device, 172.19.30.8, was trying to infect anything it could on the network? Well, in this case, what I would do is actually not apply it to F01 in the outbound direction or to F00 in the inbound direction, because now that's only protecting router B's network attached to F02 and our server network. I could put it on router A on F01 in the outbound direction, but that's not doing much different than when I applied it to router B's F00 in the inbound direction. My personal opinion is the most effective place to put this standard access control list is closest to the source. Well, if 172.19.30.8 has a virus on it and it's infecting other equipment on our network, and I want to stop that, and I don't have the ability for whatever reason to turn off that PC, I can put this access control list on F00 of router A, and that will instantly stop any traffic coming from that device getting out onto the rest of the network, and it'll still allow the other devices to communicate. I'm sure you can find 1,000 holes in my example about how viruses propagate and whatnot. My point here is that if one of our devices on our network is causing some traffic that looks unusual or is nefarious or is too much traffic or anything like this, we can use a standard access control list to simply stop that traffic from propagating onto our network.